All of you, welcome to the subject of basic thermodynamics, chapter number 1, video number 5. In this video, we are going to see these four topics. First topic is about the property, state, path, process, cycle. These are the basic concept terminology. Next topic, reversible process, quasi static process. Fourth topic is irreversibility and its causes. Okay, we will see one by one. The first topic in this video is the property, state and path and cycles. The basic definitions we will see. First, the property. The previous video we seen about the property in detail. Once again I will repeat the property. Every system has a certain characteristics by which its physical conditions may be described. Example, volume, temperature, pressure. Such a characteristics we call as a property of the system. Okay. Next, we will see the definition of a state. We all know. Okay. What is the state? When all the properties of the system have a definite value, the system is said to exist a definite state. Okay, I will write the definition. Okay, the definition of the state. When all the properties of the system have a definite value, the system is said to exist a definite state. Next is the path. A series of states through which the system is passes, going from one initial state to the final state. It constitutes a path. See, when the system is a passes through one state to the another state, from one initial state to the final initial state, we can call it is a path. Okay, what is the we have to look at here is the a series of state. These are the a series of states through which the system is passes, going from initial state to the final state. It constitutes a path. Okay, I will write the definition. Okay, this is the definition of the path. A series of states through which the system is passes from one initial state to the final state is constituted path. Okay, next definition is the process. When the path is completely specified, the change of the state is the process. When the path is completely specified, when the system changes from one state to the another state, this is the change of state is known as the process. This is the process. When path is completely specified, the change of state called as a process. Next, we see the cycle. Okay, next basic term is the cycle. Cycle is a series of process can put together such that the system returns to its initial state is called as a thermodynamic cycle. Okay, this is a process and system changes its states through a process from state 1 to state 2. This is the initial state and system returns to its initial state. Okay, the system is, this is a one process, this is another process, and a series of process can put together such that its initial state, okay, the system returns to its initial state called as a cycle. Okay, thermodynamic cycle we call it as a simply a cycle. Okay, the second topic in this video Is the reversible process. The second topic in this video is the reversible process. When a system changes its states undergoing a condition where the driving force is zero, the system is set to undergo a reversible process. A reversible process can proceed in either direction. Okay, when system undergoes, okay, when system is changes from one state to the another state, okay, one state to the another state with the driving force, maybe the pressure or temperature. Driving force should be the zero. With the driving force, with the zero driving force, if the system is changing from one state to the another state, okay, another state, it is the reversible process. It is a reversible process. It should be, it can be, it can reverse. Okay, it can be reverse, it can be reverse at any position, okay, without affecting on the system and surroundings. Okay, that is the main criteria for the reversible process. A process is said to be reversible if the both the system and the surroundings can be returned to or restored to their initial states by reversing the direction of the process. That is the main criteria for the reversibility process. Okay, it is clear. Once again, when the system changes its states undergoing the condition where the driving force should be with the driving force zero, the system is undergoing a reversible process. The reversible process can be go in either direction. It can go in either direction without affecting the system and surroundings. It should be reached to its initial position. That is the criteria for the reversible process. We will see the examples of the reversible process. Example of the reversible process are the extension of spring. This is the example for the reversible process. Extension of the spring. This is the helical spring. When the appropriately varying force is applied on the helical spring, it will extend by the small amount. We will say it is the x1 is the, maybe it is the extended by applying the force in the first case. Samely, if you apply infinitely small amount of if you release this infinity small amount of force in the second case, it will restore to its, by moving the same x1 distance, it reaches to its original position and its original position. Okay, thus within the limits, the extension and compression of the spring, it comes under the category of the reversible process or reversible process example. Next example is the a frictionless adiabatic compression and expansion of the gas. Second example is the frictionless adiabatic expansion and compression of the gas. This is the adiabatic wall. This is the piston cylinder arrangement. Inside is the gas. Okay, this is the adiabatic. First is when the small amount of the force is applied on the piston. The piston initially the gas molecule force and the piston, it is in a position of equilibrium. When the infinitely small amount of force, we call it is a delta F. Initially two forces. Okay, initially here gas molecules, it is a piston. Initially, these two forces, the molecular force inside the gas and the piston force, is initially at the equilibrium. When we apply a infinity small amount of force, the piston will move against the molecule, so the molecules will, okay, will get come to close. Now the position of the piston may be the this, okay. Due to this, the, okay, if we release the, this is the first case, the piston moves to this position. In the second case, if we release the same amount of force on the piston, release the same amount of piston, the piston will regains to its original position there. So the molecules in the gas also, it comes to the, it's the initial position. Okay, this changing the displacement of the piston up to the certain limits only, it is in the case of the reversibility. So the expansion, while applying the force, it is under the compression of the gas. When we release the force, it is under the expansion of the gas. So it can after releasing the force, it can able to regain its original position. So it is under the example of the reversible process. Next examples are the isothermal expansion or compression of the gas. Third example in the reversible process is the isothermal expansion or compression. Here also piston cylinder arrangement, inside is the gas molecules. Okay, whenever the, okay, first whenever the heat source or heat source is the heat source. Heat source, if you come to closer to the piston, okay, piston cylinder arrangement near the cylinder, due to the heat supply inside the inside the cylinder, the molecules gets excited and expands by the small amount. The piston may initially here, the cylinder will expand by the small amount, maybe the x1. Okay, this is the case 1. Okay, this is the process, let it be the 1 to 2. Okay, okay. Next, when we remove this, when we remove this heat source, okay, when we remove the heat source, initially let it be the temperature at T1. When the heat source temperature, which is the T2, which is greater than the T1, so because of the temperature difference, which is the higher temperature, so the heat transfer towards the gas molecules. Because of the heat transfer, the gas molecules gets excited and it will move, and it makes extend the piston toward the outwards. Okay, in second case, if you keep the heat source, which is the T3, which is the less than the T1, now this case, heat will flow from gas molecule to the outside the source temperature, outside the source material. Okay, in this case, the gas molecules, because of the temperature difference, which is lesser temperature outside, so the heat will flow from here to outside. So gas molecules reduces their energy level. Because of this, they will get compressed, so the piston will move to the somewhat some distance. So from this, it is clear that under up to, it is very important that up to certain limits only the extension, the expansion of the cylinder and compression of this cylinder will happen. Such a case also comes under the isothermal is the reversible process only. Okay, now we move to the third topic. In this video is the quasi-static process. Okay, the third topic in this video is the quasi-static process. First, we see the quasi. Quasi means almost. Here is the quasi means almost infinity slowness. Infinity slowness is the characteristic feature of the quasi-static process. Now we see the definition. When a system changes its states very slowly under the influence of infinitesimal driving force, that is the delta P delta T, the system is set to undergo a quasi-static process. Now I will write the definition. Okay, see the definition. When the system changes its states, state 1 to the state 2 very slowly under the influence of the infinitesimal driving force of the system is set to undergo a quasi-static process. Only the difference between the reversible and quasi-static process is the in reversible process the driving force is completely zero. With the zero driving force, if the system changes from 1 to 2 is the case of reversible. In case of the quasi-static process, with the infinitesimal driving force, very small amount of driving force, the system is changes from one state to the another state is set to undergo a quasi-static process. Generally, the system undergoes a process. It may be necessary to disturb a system to drive to the desired direction. Suppose this is a system. Okay, here the temperature may not be completely uniform. Okay, if the energy to transfer across the boundary as a heat. Okay, now the system may not be completely uniform. Okay, with a little bit variation, temperature is enough to cross the energy as a heat transfer at the boundary. Similarly, pressure also may not be in case of the pressure. In case of the pressure also, pressure may not be completely uniform. Okay, may not completely uniform if the boundaries to move and create a volume change process. Okay, similarly, when this deviation from the equilibrium is very small, we can say this process is the quasi equilibrium process. The deviation from the equilibrium process is very small. The deviation of the equilibrium is very small. We can say this type of equilibrium is a quasi equilibrium process. Okay, and we assume it is a complete thermodynamic equilibrium. Okay, while those occurs relatively rapidly. Okay, this process will occur very compared to reversible. This is very relatively rapidly, may deviate from significantly from the equilibrium. Okay, in case of the reversible process, it will take infinity time. Okay, it have infinity time to change from one state to the another state in case of the reversibility compared to or relative to the reversible process in case of the quasi equilibrium relatively rapidly. Because of this, it may deviate significantly from the equilibrium. Okay, now it is clear about the quasi static process. It is a infinity slowness process. It is the infinity slowness process, but with a infinity small amount of driving force only the process occurs. That is a remember. Next, fourth topic is the irreversibility. Okay, the fourth topic in this video is the irreversibility. First we see, already discussed about the reversibility first. Okay, by this compare, it is very easy to tell what is the irreversibility. In the reversibility, if you remember, reversible process caused out infinity slowly with the infinity small amount of gradient, so the each and every state passes through the system is in the equilibrium state only. Okay, whatever the process take place in the reversible process, from one initial state to the final initial final state, with each and every state under the equilibrium condition only, that too with the infinity small gradient force, with the infinity small gradient force. Okay, under the infinity small gradient force, and the reaction also take place infinity large time. Okay, infinity large time, or we can say it is a infinity slowness the process will take place, and it will also it can able to reverse at any position. Okay, without disturbing the without okay without disturbing the system and surrounding, disturbing the system and surroundings. This is the criteria for the reversibility. If any process, if we break any one of this rule, it comes under the irreversibility. So it is very easy to find the what is the particular process is under the irreversibility or not. Okay, it is very difficult to establish for a reversible process, but irreversible process, however, are relatively easy to recognize, because one of the element in the irreversibility is established, the process becomes a irreversibility. Okay, that is the irreversibility. But in the natural process are carried out with a finite gradient force only. All the natural forces, all the natural processes, all the natural processes carried out the finite gradient forces only, with a finite gradient forces only. When the system have to change from one state to the another state by the finite gradient forces only, in all the natural process under the action of the finite gradient process forces only. So all the natural forces comes under the irreversibility. Okay, irreversibility. Here time also very important. If the okay, here time also very important criteria. If your time is allows to infinity slowness, but under the action is a finite gradient only. So because of these two rules cannot be obey the any general processes. So almost every process occurs is comes under the irreversibility only. For this way, okay, next another important in this related topic is what are the causes of the irreversibility. Okay, irreversibility may be the due to the either two reasons, or maybe the combination of the two reasons. One is the lack of equilibrium during the process. Whatever the process is taking place, because of the lack of the equilibrium during the process. Next, the involvement of the dissipative effect, we will see clearly. Okay, the causes of irreversibility. The irreversibility may be due to the either one or both of the following reasons for the irreversibility. The first one is the lack of equilibrium during a process. Irreversibility due to the lack of equilibrium. The equilibrium may be the mechanical, thermal, or chemical. Okay, any lack of equilibrium between the system and surroundings, or between the two systems, or maybe the two parts in the system, causes the spontaneous changes, which is a cause for the irreversibility. We will see one by one. Okay, the following are the examples for the regarding the lack of equilibrium during a process. First one is the heat transfer through a finite temperature differences. Heat transfer process approaches a reversibility when the temperature difference between the two bodies approaches delta T is a zero case, and we define this is a reversible heat transfer process as a one which is the heat transfer take place through at a infinity small temperature difference. Under this condition we treat it is a reversible process. Okay, for a infinity small difference of the temperature to transfer a finite amount of q, they required infinity time or maybe the infinity amount of area contact is required for a reversible process. For a reversible process with a finite temperature difference only, with the finite temperature difference, if the heat transfer is taking place from one body to the another body, that too with with a finite time. Okay, with the finite time, so this this process is the irreversible process. Okay, the greater temperature difference between the two bodies, it will rise to the greater irreversibility. This is the one of the example. Next, this is one of the reason why the lack of the why the causes of the irreversibility. Because of the here, what is the lack of the equilibrium is the temperature difference. The temperature is not uniform, so this is the lack of the under the condition of the lack of thermal equilibrium, the irreversibility occurs in this case. Okay, lack of thermal equilibrium, heat transfer taking place. So wherever the system is lack of thermal equilibrium is is present, there is a heat transfer, that is the comes under the case of the, okay, heat transfer through a finite temperature difference. Similarly, pressure also. Okay, lack of the pressure equilibrium within the interior of the system or between the two systems with the surroundings, also the one of the cause for the irreversibility. Next cause is due to the chemical equilibrium, lack of the chemical equilibrium. Okay, the word, the lack of equilibrium because of the three lack of equilibriums. One is the mechanical equilibrium, thermal equilibrium, next is a chemical equilibrium. Because of this three lack of equilibrium, there is a chance or maybe this is the reason for the cause of the irreversibility. Now we seen the first example of the heat transfer. Okay, second one is the due to the lack of the pressure equilibrium. When there is when there is a system exist between the pressure. Okay, when there exists a difference in the pressure between the system and surroundings or within the system itself. Okay, both the system and surroundings will undergo a change of the state. Okay, this is the system or surroundings. System and surrounding, when there is a pressure difference, when there is a pressure difference is occur, there is a change of state. Okay, there is a there is a the process undergoes a change of the state. This will cease only when the system is under the mechanical equilibrium. Until it is not under the equilibrium, there is a change of the state, but it won't be reversed by its own. Okay, if it is goes by its own, it is a violation of the second law of thermodynamics. And next is the free expansion. Due to the free expansion, also the reversibility causes expansion. The free expansion comes under the category of due to the lack of the chemical equilibrium. Comes under the category of the lack of chemical equilibrium. Let us consider an isolated container. Let us consider an isolated container. This container which is divided into the two compartments. That is that is compartment A and compartment B. But these two compartments are separated by the diaphragm. And if the diaphragm is punctured, initial conditions I will tell. First, in this the compartment A is contained a mass of gas, and while the compartment B is completely evacuated, it is empty or vacuum. This is the initial. When if you make some hole in between, now the gases are allowed freely to occupy until when the both system under the equilibrium condition. But we cannot reverse. Okay, we cannot reverse back due to the chemical equilibrium. Due to the lack of the chemical equilibrium, we cannot reverse by its own. Okay, by until another device we can make it. Okay, but its own it won't be possible. Again, it is the violation of the comes under the second law violation of thermodynamics. Next, the second reason for the causes of the irreversibility is the due to the dissipative effects. We will see the second main reason. Okay, it is clear what is the reason, how this reason affecting the irreversibility is whatever the amount of work is done is not converting completely because of the dissipative effects. The some part of work is converted into the losing in the form of internal energy storing in the system or in the surroundings. Okay, due to the reason of the friction, viscosity, inelasticity, electrical resistance. Okay, we will see one by one. First we will see the friction. Generally, the friction is always present in the moving devices. Generally, friction is always present in the moving device, unless when the friction may be sometimes may be the reduced because of using a suitable lubrication, but it cannot be completely eliminate the friction cannot be completely eliminated. Okay, it won't be possible. If it is possible, it is comes under the perpetual motion of the third kind only. Okay, it won't be execute in the nature. Okay, we will see the example. This is the body. When we lift the weight, okay, when we lift the weight, the body will move down. Okay, moves down. But whatever the potential energy we are in the form of potential energy we are lifting the weight, that complete energy is not converting or utilizing to move the body, because some part of energy can be dissipated in the form of the due to the friction. It will oppose the body to move in this direction. Okay, it will make to move friction in this direction. The body is supposed to move in the downwards. Some part of energy is dissipated in the form of the friction. Next is similarly the pedal wheel work transfer also. This is the second example in the dissipative effect is the pedal wheel work transfer. When the rotation of the pedal, the inside of the, okay, first we will explain. This is a container, a insulated container, inside a fluid, and it is a rotary fan. When we make a rotation of this fan, because of this rotation, this rotational energy can, because of this rotation, the molecules will keeps on moving in the random motion, so the temperature of the molecule will rise. Okay, due to the work, because of this work transfer of the rotation, Work transfer of the rotation, the molecules in the water molecules in the container, the temperature will rise in the first case. Okay, but we cannot go in reverse. Okay, we cannot go at the reverse by its own. Okay, by its own. So this is the some amount of heat is dissipated. So this is another why the causes of the irreversibility. The reverse, whatever the work is done to raise the temperature of the water molecule, we cannot reverse exactly with the same amount of heat. If you supply, we cannot draw the same amount of work in the reverse direction due to the dissipation of the work. This is the second example. Similarly, the transfer of electricity through the resistor also, there is a some dissipation of the energy in the form of the temperature. Okay, thank you. I think this is understood the causes of the irreversibility. The causes of the irreversibility maybe the two reasons. One is the lack of equilibrium during the process. Second one is the involvement of the dissipative effects. These two are the main causes for the irreversibility. Thank you. We will discuss the four topics completed in this video.